we want to evaluate the integral of dy over the square root of 33 minus 8y minus y squared. So we are going to apply the substitution rule for leading to inverse trigonometric functions, but we need to perform completing the squares for this particular example. So to do that, we have dy over, so we isolate the constant 33 from the two other terms with variables. Then we want to make sure that the coefficient of the quadratic term, that is y squared, we want to make sure that its coefficient is positive 1. So since the coefficient is negative 1, we will factor negative 1, and negative y squared becomes positive y squared, and negative 8y becomes positive 8y. Now, we want to add an appropriate term to 8y squared plus 8y so that it becomes a perfect square trinomial. So, the number that we need to add would be, so we need to divide the middle term, or we need to divide the coefficient of the linear term by 2. So 8y, we divide 8 by 2. So that would be 4, and then we square that. So 4 squared will be 16. And this same value, we need to combine that with 33. However, since 16 is inside the parentheses and negative 1 is distributed to 16, so technically what we're adding to the expression is negative 16. So in order for negative 16 to be cancelled out, we need to add positive 16 to 33. So you have to take note that if you try checking if you were able to perform the completing the square correctly, you try to simplify the expression inside, and it has to be the same as the original expression. So if we do that, we have 33 plus 16 is 49, minus y squared minus 8y plus 16, and then 49 minus 16 is 33, minus 8y minus y squared, and it is still the same as the original expression in our given. So this means we were able to perform the completing of the squares correctly. So let me erase this and continue with our solution. So we have dy over 33 minus 16 is 49, minus, we now factor our perfect square trinomial, so it will be the square root of the first term, so meaning y squared, the square root is y, square root of the last term, so 16, the square root is 4, and then sign of the middle term, so 8y, since it's positive 8y, we will use the sign of the middle term, so that would be positive, and then quantity raised to 2. So we were able to convert our given into a form that is similar to the form for leading to inverse trigonometric functions. So here, we let a squared be 49, which means a is 7. So we're going to use positive 7. And then our u squared will be y plus 4 quantity raised to 2. Therefore, our u will be y plus 4. And then we get our du. And this will be 1 dy. So if we perform the substitution, just so you can see our transformed expression, so it will become, dy will become du, and then we have square root of, so 49 will be replaced by a squared, and then y plus 4 quantity squared will be replaced by u squared. So this is the form under substitution rule for leading to inverse trigonometric function whose answer is arcsine. Sine inverse or arcsine of u over a plus c, and then we perform back substitution, it will be arcsine. So u will be y plus 4 over the value of a, 7, plus c. So this is our final answer. Let us evaluate the indefinite integral dx over 4x squared plus 8x plus 13. We are going to apply completing the squares so that the given will be transformed into a form solvable by substitution rule for leading to inverse trigonometric functions. So to do that, we will be isolating the terms with the variable and then the constant. So we have 4x squared plus 8x, and then we have plus 13. Next, we will make the coefficient of x squared, the quadratic term, 1. So to do that, we will be factoring out its coefficient of 4. So we have 4, and then we'll have x squared because we've already factored out 4. And then instead of writing 8x, we will be dividing 8 by 4 since we have factored out 4. So you will be left with 2x here and then plus 13. Now we need to identify a number that we should add to x squared plus 2x so that it becomes a perfect square trinomial. That number will be half of the coefficient of the linear term, so meaning half of the coefficient of x. So that would be 2 divided by 2. So we get 1. And that value will be squared. So we square 1 and that is 1. Now whatever we added to our expression must be subtracted to the constant. So we added 1 inside the parentheses. However, since 4 is distributed to 1, so technically we added 4 to our entire expression. So we need to subtract 4 from 13 so that the answer or the expression in the denominator will be exactly the same as the original given of 4x squared plus 8x plus 13. So simplifying, we have dx over 4 x squared plus 2x plus 1. So 13 minus 4 is 9. So next, we have dx over 4. We now convert our perfect square trinomial of x squared plus 2x plus 1 in a factored form. So we get the square root of the first term. So square root of x squared is x. Square root of 1 is 1. And then sign of the middle term. So the sign of 2x is positive. So we write here plus. Then quantity squared, we have 9. So we are now able to convert this into a form that is solvable by substitution rule for leading to inverse trigonometric function, where we let a squared be 9, which means the value of a is 3. And then u squared will be 4 times the quantity x plus 1 raised to 2. Therefore, the value of u is the square root of 4 times x plus 1 raised to 2, and that would be 2 times x plus 1. du will now be 2 times the derivative of x plus 1, that would be 1, and then we write dx. So for this one, we need a correction factor since we need 2 dx. So we need to put in 2 on our numerator, and then outside our integration symbol, we need to put the correction factor of 1/2. So therefore, our given will be in the following substituted form. So we copy 1/2. 2 dx will be replaced by du over 4 times the quantity x plus 1 squared will be our u, and then 9 is our a squared. So this is now the form solvable by arctangent. So we write 1/2. So the formula for arctangent is 1 over a. Arctan or tangent inverse of 1 over a or u over a. And then you have plus c. We perform back substitution. We have 1/2. 1 over the value of a is 3. And we have arctan of u. So u is 2 times x plus 1 over 3 plus c. So we just multiply 1/2 and 1/3. So we get 1 over 6. Arctangent of 2 times x plus 1 over 3 plus c. So this is our final answer.